All right, let's jump right in. We are going to be exploring one of the most powerful ideas from the legendary book, The Pragmatic Programmer. It's this philosophy from Chapter 4 called Pragmatic Paranoia. And you know what? It's all about taking that little nagging fear that every single developer has, that fear that something somewhere is about to go wrong, and turning it into your greatest professional strength.
So the whole thing starts with this one simple and maybe a little bit of a painful truth. You can't create perfect software. It's just a fact. Nobody in the entire history of computing has ever done it, and let's be real, we're probably not going to be the first. But here's the secret. Embracing that fact isn't a weakness at all.
Because you see, the second you accept that software lives in a messy, imperfect world, and that your code is going to have flaws, you stop chasing this impossible dream. And instead, you start building for reality. You start creating systems that are actually robust, that are resilient, and are totally prepared for the unexpected. Accepting imperfection, well, that's the very first step toward true professionalism.
Okay, so how do we actually put this into practice? I want you to think about it this way. Just like we all drive defensively to protect ourselves from the absolute chaos on the road, we have to learn to code defensively.
You know, the analogy is just perfect. When you're on the road, you don't blindly trust other drivers to follow the rules, right? Of course not. Well, in code, you can't blindly trust some third-party API to always send back valid data. You watch out for potholes and bad weather on the road. You've got to anticipate system errors like a full disk or a dropped network connection. But here is the most crucial part. Pragmatic programmers don't even trust themselves. They know they're going to make mistakes, so they build defenses against their own inevitable errors. So, if we can't trust anything, how in the world do we build reliable software? Well, we create trust. And we do that by setting up really clear, enforceable agreements right there inside our code.
This whole idea is called design by contract. Just think of it like a legal agreement for every single function or method you write. It's a way to formally document the rights and responsibilities of both the code that's calling the function and the function itself. It's all about making those interactions predictable and, most importantly, safe.
So every one of these contracts is built on 3 pillars. First up, preconditions. These are the rules the calling code absolutely must follow. Think of it as making sure a user ID is a valid, positive number before you even try to look it up. Second, postconditions. This is the function's promise back to you. It guarantees that if the preconditions were met, your update user function actually, updated the record. And finally, invariants. These are the fundamental truths that should always be true, like an account balance never, ever dropping below its credit limit. Put them all together, and these pillars create an incredibly powerful safety net.
Okay, but what happens when a contract gets broken? Well, this leads to a concept that feels a little weird at first, but it is absolutely vital. Sometimes, the safest, most professional thing a program can possibly do is to just stop, dead in its tracks.
The book puts this so perfectly with this quote. A program that crashes right away tells you the truth. It tells you exactly what went wrong, where it went wrong, and why. It basically gives you a clean crime scene to investigate.
I mean, really think about it for a second. What's the alternative? A program that hits an error but just keeps on running, silently corrupting your data, writing total garbage to your database, and spreading bad information all through the system. By the time you finally notice, the damage is everywhere, and it's almost impossible to trace back to the source. A clean crash is always, always better than a silent failure.
And that right there is the whole idea behind assertive programming. It's how you actually put the fail early philosophy into practice. You just sprinkle your code with these little checks, these assertions, that look for things that should be impossible, like, say, a variable that's supposed to hold a discount percentage suddenly being greater than 100. If that impossible thing ever happens, the assertion fails, and the program halts immediately, telling you loud and clear that one of your basic assumptions about how the world works was just flat out wrong.
Now, this whole defensive mindset, it's not just about data and logic. It also applies to how we manage finite system resources, things like memory, files, network connections. The core principle here is so simple, but it's really profound. Always finish what you start.
The key here is to have a super clear policy for resource ownership. The rule of thumb is basically this. The function or object that allocates a resource is also responsible for deallocating it. Simple. If you open a file, it's your job to close it. If you grab a block of memory, you have to be the one to free it. This simple discipline prevents resource leaks, which, as you know, are a huge source of instability and crashes, especially in long-running applications.
So after all this talk about contracts and crashes and paranoia, you might be thinking, wow, this sounds like a lot of negative, fearful thinking. But actually, the exact opposite is true. This isn't about fear. It's about control. It is this disciplined, defensive mindset that, in the end, actually sets you free.
And why does all this matter? Just look at the payoff. Your code becomes way more robust, debugging is 1,000 times easier because bugs announce themselves immediately instead of hiding for weeks. You get fewer nasty surprises in production, you build a reputation for quality, and your code becomes a professional asset instead of a ticking time bomb.
So I'm going to leave you with a little challenge. Think about the code you're working on right now. What is the one impossible thing that you're just assuming is true? A pointer that's never null? A value that's never negative? Go find it, and just add one assertion to check it. I promise, you might be surprised by what you find.
You know, in the end, all of these techniques, defensive coding, contracts, assertions, they all come back to this central theme of the book, craftsmanship. The artisans of old, they would sign their work. It was a mark of pride, a guarantee of quality. Coding defensively, that is how we, as modern craftspeople, sign our work. It shows that we care enough to build things that are solid, reliable, and absolutely worthy of our name.